The topic for the talk in the next few minutes is non-intrusive code coverage. So you may know that the UDE, our tool for debugging test and trace, is not only intended to find bugs. It's also a tool that supports you while you test your software at the end. For that, UDE provides a lot of features that help you to execute automated tests on the real hardware, for example, using our script API, or if you connect a third-party tool or third-party test tool to UDE. But a test alone is not sufficient, especially in the field of safety-critical applications. And there comes UDE also into play. If you look at the current standards in that field, for example, the ISO 26262 for automotive applications or DO 178 for electronics in avionics, then you will see that not only the test itself is addressed in great detail, but also the evaluation of its significance and quality. One of the metrics that we know for evaluating and ensuring test quality is code coverage. Basically, code coverage indicates how much code was actually executed, triggered by the test cases. If you look at this example, we have a piece of code here, which is stressed by some test cases. And if you feed in, for example, one test case, then only a certain piece of code is executed. You need another test case to execute, for example, another part of your code. And finally, in this specific case, you need also a third example or a third test case to execute finally all the code that should be tested. For the code coverage, which I've shown you here is in this little picture, we know different levels. The simplest level is the so-called statement coverage, which gives you the ratio between the executed statements or instructions compared to the statements or instructions that exist for the module or the function under test. But the statement coverage itself tells you nothing about the conditions in the code. To ensure that also all the passes of the conditions are tested, you will need at least a branch coverage which gives you the information about that. The branch coverage gives you the ratio between the taken branches compared to the overall number of possible passes through your code. Before we go further into details here, I want to give you an important note. The coverage or the code coverage tells you nothing about the software quality of your product. It tells you only about something about the quality of your test cases. The next example I'd like to show you is an example which visualize or which shows us the principle of the branch coverage. For testing this piece of code here, it would be sufficient to use as a test case x minus 7. All the instructions of this code are executed. It's good for now, but not enough. If you look at the graph here, the so-called control flow graph, then you will see that there is an edge not executed. This is the fall through through this if statement here. So if you want to make sure that also this not taken pass is triggered by the test, we need another test case. For example, if we provide 7 as the next test case. So what we did here to measure the code coverage is we executed the test. We observed the instruction flow, especially with the edges here of this control flow graph. And then finally, we evaluated and calculated the coverage. So with these two test cases shown here, we reached a branch coverage of 100%. So, and how do we do that? How do we observe the code execution and gather the data that we need to calculate the code coverage? So basically, there are two ways to do that. The first way is we can instrument the code. So the code itself, the executed code itself, observes all the edges that are triggered by the test cases. This instrumentation is done by a lot of verification and test tools on the market. The great advantage is that you can do the tests at your PC running a simulator or something like that. It's completely target independent. But if you change to the real hardware, then I guess you get some undesirable results. It changed runtime behavior at first to the additional code that you get with the instrumentation. It's obviously that you change the runtime behavior. And you have also a changed code size by the addition code for the code coverage. And possibly you need to save the coverage results at your target. You get a different memory layout because of these collected data. At the end, you have to be aware that the code under test, in this case, is not the code that you will later which will be later used in the final product and in the field. The second approach relies on trace. This is a hardware feature that we are utilizing by the debug tool. And this method is completely non-invasive. That means I do not need any code instrumentation to get the data out of the executed code. But there is maybe a drawback. This coverage approach gives you only the coverage at object code level because you are observing the executed instructions, the executed machine instructions. This may be a disadvantage, but in my opinion, it could be also an advantage because you get the coverage for your tests that are executed on a real code, and that is in most cases also optimized by the compiler, and that's the code finally in your product. But the real drawback is in some specific cases that with highly optimized code, we miss in the tool some information about the real control flow inside the code. So this may lead into incomplete coverage results, but there is a solution for that. We can rely on specific information that some compilers gives us to provide additional information about the control flow. Before I show you the demo, let me summarize the set. So first, with trace-based code coverage, you can test the real hardware. This is an important point. The code coverage based on trace is at object code level. We see later how this works. And for highly optimized code, we do some support by the need some support by the compilers to get important control flow information. But this does not mean that we change the binary of your code. This is completely untouched. These additions are made only to the debug information in the ELF file that is loaded into the debug tool. Due to the limited amount of trace memory, we are on hardware. Don't forget this. We have to partition the measurement of the code coverage into, for example, functions or modules. So test tools that are using this approach with UDE provide this functionality by themselves. So they are breaking the functions and the executed code into pieces, test these small pieces, and get the code coverage results also from them. And the results are then accumulated. Okay, let's finally jump to the UDE. So you should see the UDE now. Let me check. Right. I have already opened a workspace in UDE. That means a pre-configured debug session. In this case, on a AUX Infineon microcontroller that is equipped with trace. And for this, I use the MCDS trace unit on this device. So the first thing I have to do is, of course, run the application, feed some test cases into the application. This is done by this value here. This gives us the number of test cases, different test cases for the functions under test. And finally, I need to set up the trace. The steps I'd like to show you now are done typically automatically by test tools, but I have no test tool connected here at the moment, so I have to do this manually. I open the trace configuration, which is handled by our UEC tool, which allows us to configure the MCDS trace to capture some trace information of a piece of code in my application here. I've prepared already a trace configuration. You can do it from scratch, but for now, because of the limited time we have, I have already prepared one. It simply traces between two functions here, trace on and trace off, and saves all the executed instructions in between. And from this information, we can calculate the trace, the code coverage. So let's get started. Start the trace recording. It took some seconds to prepare the trace and to capture the trace. So finally, we get the result in the trace window, and also we get this result in the code coverage window, which is here on the right side. You see, we have executed some code on core 0. In the trace, we have 5 functions, and the coverage for those, we can see that we have a so-called line coverage and also a so-called MCP coverage. Line coverage is equivalent to the statement coverage on object code at the object code level, and MCP coverage is the machine code branch coverage, also the branch coverage on the object code level. So if you look at this function 1, for example, this test function 1, you see, okay, we have 100% statement coverage here, but only 75% of branch coverage. That means that we have reached, if you look here into the function, we have reached all the instructions down to the machine code in this example. But you see here in this specific line that we have for the last else if branch not taken all possible passes. So the fall through path through all the if statements of this function was not tested by our test case. And if we want to test also this fall through, then we have to change the number of test cases or add a new test case. I can show you that by changing this value to 4, for example. Then we start the trace recording again and wait for the code coverage results. And finally, we get a result of 100% statement coverage, that's what we expected, and also 100% of the branch coverage. And you can look at this machine code representation here, and you see, okay, we have also tested the fall through parts of this jump instruction here of this branch. We can also switch from here to the code, and you see the assembler code here at this the source code at this level with green bubbles here on the left side indicating the statement coverage. And also I can switch to the mixed mode where I can see the statement coverage of all the executed machine code instructions. Okay, finally, you can also create a report with from the code coverage result, which can be then saved. In this example, I use HTML as an HTML report, which gives you all the information needed to document your tests. With the new version of UDE, the UDE 2021, we added some other export formats for the reports. CSV, XML, plain text is also now possible.